Hi Akram, is the sound working? Just let me know it's working alright before we make a start. Perfect. Okay, so this is just a drop-in session, Q&A session, so if there's anything in particular you want to ask about, if there's any specific topics or questions you want to go through, then feel free to let me know in the comments, and I can see what I can do, if I can bring up any specific questions or examples of a topic you want to look at. Okay, so you want to level up from a 7 to an 8. So I guess that's just gaining extra marks generally, isn't it, to push you into the next grade boundary? I don't know if there's something that you've done in your past papers that you feel like is a recurring theme, or somewhere where you specifically lose marks, or is it kind of a general thing, just so that you don't then end up making enough marks to get, to a grade 8 on the grade boundary scale? Yeah, I think vectors, at least for me, is probably the hardest topic on the whole syllabus, but that, I guess, often comes up, doesn't it? And conditional probability. Yeah, probability will always come up somehow. Yeah, we can have a look at those topics now. How do you do as many past papers as possible? I guess you just have to set aside the time, isn't it? The thing about the past papers as well, though, is don't just do the past papers. Make sure you also spend, I don't know, 20 minutes marking it as well. So get the mark scheme up. It's on the whatever exam board you are, Edexcel, AQA, OCR. You'll have the mark schemes on the website as well. So make sure you go through the mark schemes and mark your own work, because not only then does it give you feedback as to whether you did get something right or you did get something wrong, but also it helps you to get to know the mark scheme and how they are going to be assessing you. Because then, some of the questions are kind of similar over the years. They obviously can't vary it that much. So you end up going, oh, I might have seen this before, and I remember that in the mark scheme it was looking for this specifically and this thing. So that's also really helpful. Don't just do the papers and leave it. You need to get that feedback yourself, and you also need to familiarize yourself with your specific mark scheme. That's also super important. So yeah, it's not just doing the past papers, but actually marking them as well. Because also if you get someone else to mark it, then okay, yeah, you get feedback in terms of what you got in terms of marks, but it doesn't help you to familiarize yourself with the mark scheme. So I think that is also part of your revision, is finding time to mark it yourself and really pay attention to the mark scheme as well. So I would really, really recommend that. That also works for other subjects as well. I did that for science, because I found that for science I kind of knew what the content was. I'd learnt the content, but I still kept getting the answers wrong because I just didn't know what they exactly wanted me to write. That's maybe more so for science and other things, but yeah, it helped to kind of familiarize myself with the mark scheme as well. But yeah, it's just creating a revision timetable, really, because also I know you got maths is obviously quite important, but then you've also got your other subjects as well, haven't you? You've got to try and balance everything. Yeah, so I already have videos on vectors and circle theorems. I'm about to bring up a vectors one, because that one tends to come up quite a lot. So we're about to go through one of those now anyway, but I do have videos on them as well. If you have a look through my my channel, there's a couple of vectors. There's 2 vectors videos, so it's split into. Sometimes they ask you to prove that 2 vectors are parallel or prove that they're on a straight line. That's one video. And then the other video is, I call it ratio and scale, you know, and it says work out the ratio of these two these two parts of the line or the vector, right? Or work out the scale k or something like that. That's the other one. So I have got videos that I've concisely edited as well. Yeah, exactly. I've done one on that. But we can go through it now anyway, because a lot of people have been asking for vectors. It's quite hard, but I feel like if it's the one that I'm thinking of, and there's quite a few of these repeated actually, which is good, is once you learn how to do it, it's still kind of hard, but like, there is kind of a method that's repeated, which I feel like at least that's something. At least if you want to, you can try and memorize the steps, and then if it does come up, hopefully be able to just apply the steps. Because it is that topic, that question is the same kind of, it is repeated a few times. And the parallel proof and the straight line proof of vectors, that's super easy. So if you're not sure about that, definitely go and have a look at that as well. We can go through that now as well if you want to. Let me see. It might be this one. I mean, they're all quite similar. Let me just paste one on there. I'm just working with the Edexcel exam board personally, but that's just because that's my kind of area of expertise. You might obviously have a different exam board. I think for AQA, when I looked at all the past papers, the vectors questions were mostly parallel lines, which that I think is easier. Okay, so to go from a 6 to a 7, I have got a video on how to boost your grade generally, and it's got all the different tips that I would recommend. I don't know if I already linked it in the description. I might have done. Let me check. Yeah, the first link in the description of this live, the first link is a guide to boost your maths grade. So you can also have a look at that afterwards as well if you want. Obviously, it's a case of improving how many marks you get, isn't it? Gaining more marks. So that video kind of does, it kind of goes through different ways to, you know, get those extra marks. Okay, let me make this bigger. It's slightly blurry, but hopefully, obviously, you can still read it. So I don't know if it's something like this where you have to work out the value of k, which k is obviously a scale. Well, obviously one part of it is knowing the content, right? That's one part of all of the revision picture. The next bit is then, have you done past papers? Have you gone through past papers and applied that knowledge? That's the next part. And it's kind of like exam technique, getting to know Edexcel and how they ask the questions. Because, yeah, like I said before, there are patterns. Sometimes the questions are kind of similar, and you can kind of guarantee like, oh, this question will probably, this topic, you know, is going to come up, and this type of thing might come up on the non-calculator. And, you know, I'm not saying you can predict it at all, but it's still, you know, you can start to see similar types of questions that they ask over and over. And they might put a different context, but it'll be a similar question. Oh, no, I don't. I think you're too close to the exam paper to try other exam boards. I think if you were like at the start of year 11 and you'd already done all of the Edexcel papers, then I would say, yeah, sure. But I think if you're saying that you're going to do it like next month in May, I don't think I would start mixing in other exam boards at this point. Yeah. Okay, I'm going to start talking through this one, but as I said, I do have a video on this type of thing anyway, so you can also go back and have a look at that. So this type of question is very similar every time. I mean, the setup of the question will be different, like the shape will obviously be different and the wording will be different, but the working out applies in the same way. So if you can try and almost memorize that, it's up to you really, because again, if you get to know, I don't know if you've had a look at the exam grade boundaries, because those are also on the Edexcel or whatever your exam board is. Those will be on their website. You can just literally Google it, because it's a lot, I feel like it's a lot lower than you think. So for example, sometimes I think this particular question, either you memorize how to do it Or if, let's say we go through it and you're like, I still have it still doesn't really make sense to me, and I might find it hard to still apply that to another version of this question, I would still probably struggle, then I would probably not bother with memorizing it. Like I would try and gain those marks somewhere else in the paper on a different topic, for example. That's where you've got to be strategic, because we're not aiming for 100% here. To get a 9, you wouldn't even need 100%, right? So we're not aiming to get 100%. There are things that you can kind of be like, do you know what, that topic doesn't make sense to me. I've spent this amount of time going through it and it still doesn't make sense. Then I wouldn't waste more time. I would just go, do you know what, where else can I more easily gain marks? That was one of the tips I put in the other video. So I'll show you the steps, but it is kind of niche. The other thing you can do for this question before we go through the steps is, if you also don't really know, with vectors specifically, if you read the question, you're like, I have no idea what they're asking. I don't know where to start. What I would do is I would just write down any of the vectors you can figure out, because normally the first 2 marks are just for any of the vectors. So you can normally get half of the marks just for writing down vectors, even if you're not sure if they're relevant or not. So that's the other kind of exam technique I would offer as a suggestion for this topic. If you're not sure about the working, is just don't write nothing, just write down any vectors you can figure out, even if you're not sure if it's relevant, because you just don't know. That could be the half of the marks already, and you've not even actually figured anything out, So yeah, we need to, let's see, so we need to label it, because for some reason they label some of them, sometimes they don't label them, don't know why. So we're obviously going to label it first. I think I need to make my pen a bit smaller. It's probably too big. There we go. Okay, so let's see, they've obviously told you there's some straight lines, that's fine. M is the midpoint of OB. Then they've said O to A, okay, here. So in that direction as well is A, so I always draw a little arrow. And then O to B, it's kind of hard because there's an M in the middle, but if I put it there, that whole thing is B. And then they've said A to P is obviously equal to, if you take a scale and you multiply it by the whole line. So obviously K has to be less than 1, doesn't it? Because AP is a smaller version of AB. So that's fine. I wouldn't necessarily label that just now. So given, and then this is the thing, they tend to mention that there might be, there happens to be this other straight line. So in this case, they said, given that MPN is a straight line, that's the clue. Find the value of K. So I need to draw that line as well before we even go any further. So you can always draw you can annotate your exam as you want. You can draw any lines you feel like, right? On the pictures they've given you, on the diagrams they've given you. Right, so I'm going to draw that. So what you're going to do is, do you see how that line MPN crosses through the line that we actually were asked about? Do you see how it crosses through that? So you're going to look for on your particular question, if it's a similar question to this, you're going to look for whether they've mentioned, given that this line happens to be a straight line, or one that happens to cross through the one that you actually are looking for. That's what you're going to look for. And then you have to find 2 vectors from that line. So in this case, 2 vectors from MPN. Now, you can choose any 2. You can choose M to N as a whole. You can choose M to P. You can choose P to N. You could choose it in the other direction if you want. Do you see how there's technically 3 vectors on that line? Just choose 2 of them. Normally I choose the whole line, because normally that's easier, and then I'll choose one of the smaller pieces. So that's what you need to memorize to do. So, okay, so yeah, you said AP is not half of AB, because otherwise that would just be the answer to the question, wouldn't it? Because the question is that they're asking us what is AP in relation to AB, so it's not half, because we don't know that yet. And then AN, yeah, so we can label AN, can't we? You've just said AN is obviously, yeah, MN, MP, or PN. I normally do it in that direction. You could obviously do it in the opposite direction if you want, but yeah, any 2 of those. You need 2 of them though. So yeah, AN is 2A because of this ratio here. Well, not really ratio, but that equation there. Yeah, so we can label that as well, as you said. So do you see how I could work out M to N as a whole? Like that would be the easiest one, I feel like, because it's the biggest one. Normally it's easiest to find one of the biggest one and then one of the smaller ones, but it doesn't really matter. So I would do M to N. And then it's just like imagine you're walking along a path. Like, which path can I walk along? It has to obviously have one of these A or B on it, so you can walk along it. So we're starting at M. The other thing is we're also going, I would go obviously to O. That's going backwards, isn't it, along this line? So it's going to be a minus. If you ever go backwards, you need to put negative. And because M was the midpoint of OB, it's half of B, isn't it? M to O plus O to, exactly, yeah, you're right. So minus a half B, so also that's why I draw on the arrows, make sure you get in the right direction. Yeah. And then obviously O to N is really easy, isn't it? We're going the correct direction, so A plus 2A. Now I'd always simplify it as in, you know, how with algebra collect the like terms. So that would be, I put A first, 3A minus a half B. So that would give you 1 mark already, even if you didn't know where to go from there. Yeah, exactly, you're right. That would give you 1 mark. So then I would probably do, what would I do? I think I would choose MP, but it doesn't really matter as long as you choose one of the others. Right, I'd probably choose MP. And then sometimes you realise when you're trying to work out one of the smaller ones that there's therefore other vectors you need to know first. So for example, for MP, I mean, technically you could go this way, or you can go that way. It doesn't matter, right? It would be the same thing, whichever way you prefer. Now, I think I would go, even though it's longer, I think I would go left, up and then down, just because the direction that they've put AP, MP is half of MN. No, it's not half of MN. We also don't technically know that either. Yeah. There's technically a scale for how big MP is in relation to MN, isn't there? But we don't know what that scale is. But I think technically that's not necessarily relevant. So I'm going to go around just because I think I prefer to go along AP in the direction that they've said. So A to P instead of backwards, if that makes sense. But that's just, it doesn't really matter. But I would just rather do that, like this way. So obviously I can go from M to O again, minus a half B. Then I can go up to just A, which is plus A. But then do you see how I don't currently know AP? So that's the bit I'm going to need to know. I'm going to need to know AB as a whole, aren't I? So I'm just going to write that. Got space over here. I'm going to write it over here just so we don't get confused. Before I can do M to P as a whole, I need to know AB. AB is minus A plus B, isn't it? There's normally always one that's minus A plus B, I feel like. Minus A plus B, that's the whole thing. Now, obviously, I don't know the scale of AP as a whole. I don't know the scale of that, do I? Compared to AB. But that's the whole point. So MP, AP, why do I keep calling it MP? AP, I could write it as, this is where I need to include, you have to include whatever letter they've given you. In this case, they've given us K. Sometimes they give it to you as a ratio. Sometimes they give you N. You need to include the letter that they've given you. K multiplied by the whole of AB, isn't it? And that's the scale I'm trying to calculate. I'm trying to find out. So then I can add that because I'm going in the correct direction. So I can add it. If you were going the wrong way, then obviously you can subtract it. So I've got 2 vectors. Now I'm also going to expand and simplify this one, right? So that I can get... yes, you're right, exactly. If you expanded it, you'd get minus AK plus BK. Yeah, so we're going to expand it because the next step, once you've got those 2, the next step is you want to get all of the A's together and all the B's together. You want to collect the like terms. So the second one's obviously a little bit trickier, but I'll show you how you can do that. Plus A, and then that's obviously minus AK, as you said. Well, actually, I'm going to put K first. I know normally you do it alphabetically, but technically K is the coefficient, isn't it? K is the number that we're trying to find out. So I'll put KA, and then plus KB. Now, I obviously want to put the A's together and then the B's together. So because they're not like terms in terms of this is a number and this is obviously currently a K, I would factorize. As in, so for the A's, do you see how the coefficient of that one is just like 1? It's not 0, it's 1. So I'd put 1 minus K, A. That brings the A's together. And then the same with the B's, plus, I'm going to put this one the other way around just because of the negative, right? It doesn't really matter, but I like to put the negative second. K minus a half, B. So you see how I've got something A, something B. That's what you need to rearrange it into. That's kind of like step 2, I guess. So at this point, if you stopped, without even rearranging it, right? If you left it not rearranged, this is already 3 out of, I think it's out of 5 marks. Yeah. That's already 3 out of 5 marks, and we've not actually done anything. We've just written down vectors. So even if you're not sure, because the next bit's the bit that I feel like is a bit tricky. Even if you're not sure where to go from here, you've got 3 out of 5. So I think that's a win. Anyway, so the next bit, which I think is the bit that's really confusing, and also on the mark scheme they don't really explain it very well, is what we need to do is we have to create simultaneous equations. You see why we've got two vectors, right? So therefore simultaneous equations. But the reason why I put A and B together is because I'm going to make simultaneous equations, one for the A coefficients and then one for the B coefficients. Now, this comes back to where you said about what scale is AP to AB and what scale is MP to MN. Obviously, these two are not equal to each other, are they? You can see one is clearly smaller, and we don't know that scale, which is fine. So this is where I feel like some people find it just a bit abstract, like, why are we doing this? So looking at the A's, do you see how that coefficient of MN is 3? Just 3, that's quite straightforward. And then this one has the K in it. In order to find K, we need to have an equation, don't we, basically? So, but the thing is, I cannot just put 3 equals 1 minus K, because they're not equal, are they? They're not the same length, which means they're not the same size. So I can't put them literally equal. What I need to do is, I know, because obviously they're 2 vectors from the same line, they're not the same size, but they are the same. You know when vectors are parallel, one is just a multiple of the other, isn't it? One is just a bigger version of the other. So there's a multiplier, as in another scale. But for MP and PN, or MN, whichever two you chose, it's obviously not the same K, is it? It's a different scale. So you have to bring in another letter. This is the bit where I feel like it is confusing. I tend to use X, it doesn't really matter. And what I do is I put X on the side of the equation that's a bit easier, which is, in this case, the 3. As long as you put it on the same side for both A and B coefficient equations, it doesn't matter. So X, just write it here so you know, is the scale of MP versus MN. Sometimes you end up working it out, sometimes you don't. We don't technically need to know what it is, do we? Like, we're not asked that in the question. We want to find K. So that's the simultaneous equation for MN, okay? Then I'm doing, for the A's coefficients for MN and MP. Then I'm going to do the B's. So again, I might get a different colour. This is minus a half, okay? If there's a negative, make sure you bring that with you. And then K minus a half. Again, they're not equal to each other because one is smaller than the other. So put it in the same, the same left-hand side, the same right-hand side, just so you can compare it. I can't just put it equal like this. So again, I need to use that same exact scale. So whatever scale you used for the first one, use it the same for the second one, that's fine. Obviously, simultaneous equations have 2 letters, don't they? So you can see now we've got 2 letters. The thing is that I don't really care about what X is. Sometimes you end up finding it out anyway, sometimes you just naturally do. It depends on the question, but in this case, I don't really care what it is. So these are just linear simultaneous equations. I'm going to solve it. If you think back to linear simultaneous equations, you know where you normally get rid of one of the letters first, and then you find the other. And then after that, you bring the second one back. It's kind of like half of that because I only need to know what K is. So I'm going to try and get rid of X to then be left with just K, because obviously I only care about K. So you can solve it however you want. I'm probably going to, we want to obviously get rid of the X's, right? So I'm probably going to make the second equation also equal to 3x. It can be minus 3x, that's fine, but as long as it's the same scale. So I'm going to multiply the second one by 6, times it by 6. So do you see how that would give me minus 3x equals 6k minus 3. And then, let's bring back the other one, 3x equals 1 minus k. You can rearrange it however you want. Different sign add, or same sign subtract. They're different signs, aren't they? This 3x is plus, this 3x is minus. So if I add them, they'll cancel out. Or you can just stick them equal to each other, right? Technically, you can do that. Substitution, just make them equal to each other. That's the other one. Actually, I might do that. I prefer to do that. Again, there's different ways to do it. I'm going to make them equal to each other because... Oh, no, wait, that one's negative. No, ignore me. If you'd made this positive, then you can make them equal to each other, but we haven't. So that makes 0. Obviously, we're adding... I know it's not the right way around, so you might want to write it a different way around, just so that the k's are next to each other. Minus k plus 1. Okay, so we're adding this, which gives me 5k. And then we're adding 1 plus minus 3, which is minus 2. Do you see how I've now just got an equation? Exactly. Yeah, do you see how now I've got an equation with just k? Because all I actually care about is k. I had to put the x there to make it mathematically correct, but I didn't technically care to find out what x was. So it's just like a placeholder, I guess. Obviously, then you solve it. I don't know if you can still see that. Add the 2. I just added the 2 to make it positive. Yeah, and now you can see we then divide by 5. So k, and we said before, didn't we, that k has to obviously be less than 1, doesn't it? So the fact that we've got something less than 1 kind of is slightly reassuring, at least. So there's your answer. But the problem is that all of this, well, without the answer, all of this working out for your simultaneous equations is only 1 mark. Exactly. That's only 1 mark, and then obviously the answer is 1 mark. So you might decide, do you know what, I'm going to get to there, and then I'm going to stop, because it's not worth my time to find the simultaneous equations, correctly solve them, and then get my answer. You might decide it's not worth your time, which is absolutely fine. That's your choice to make. You might go, I'm just going to get the first 2 or 3 marks by writing down different vectors, and then I'm just going to move on, because I'd rather spend time somewhere else. You might decide that. That's a valid thing to decide. I obviously can't decide that for you. That's a personal thing to choose. But yeah, the steps are create 2 simultaneous equations from a line that crosses through the one you actually want. Obviously, collect the coefficients a and b together, make simultaneous equations, and then solve them. It's kind of long. This was a good example as well. This was a short one. I've had one where we had to use a ratio, and that obviously made the simultaneous equations a lot longer to work out. And I think that was when we ended up with like a quadratic or something, and then that was a whole thing. I would say like this style of question, you know, where they've asked you for k or they've asked you for some kind of ratio, because that's all the same question. There's multiple of those questions, but they're basically the same method. You're just applying it to a different question. That's probably the hardest, I think, the hardest type of Edexcel question there is. I can't necessarily speak for other exam boards because I don't have the experience with that, but I know AQA, when I look through the past papers, it's not this really. AQA is more so vectors parallel proof, straight line proof, which that is really straightforward. So if you're doing AQA, you'll probably be fine. Edexcel, this comes up a lot, but it is this same, very similar question. So I think, from my opinion, my personal experience, this is the hardest, as in this style of question, not necessarily this one, but this style of question is the hardest. I can find one more, and then you could see like that you can see the pattern if you want. One more where because that one asks for k. There are some where they ask for a ratio, which I think it's the exact same question, but sometimes I find that means that the equations can be harder. So we could do that if you wanted. But yeah, it's up to you. You might look at this method and go, oh, that makes so much more sense now. Now I can do it. Or you might look at this method and go, yeah, that's still a bit insane. I'm just going to do the first half and then carry on. That's up to you. Yeah, well, let's do one where it's... I think this one is probably a good one. Let me just check which one I want. Do I want that one? There are multiple examples, that's the thing. So that's a good thing because it is repetitive. And if you can kind of nail down the working, then at least if it does come up, then you can go, oh yeah, it's the same question. I can do this. Maybe this one. I think this was 4 marks as well, this next one, which was almost worse because it's the same question, same amount of work, but they gave you fewer marks. Okay, let's do one more and then you can kind of see the pattern. This one actually has a part A, which obviously you should be able to get. The part A is fine. It's just the part B that's then the ratio kind of bit. Just copy and paste the second part there. So 6 marks in total, but the first 2 marks is kind of straightforward. So those are, I would say, are guaranteed, the first 2 marks. There. Okay. There's a question where you have to work out ZP. Oh, I don't know about Z. I don't know if I've seen it. Have I seen a Z one? I don't know if there was one on your mock like from last year, because that one hasn't released yet, so I won't have access to that. Like the 2024 papers, I don't think are available yet. So if it was from there, then oh no, I've seen it. Yeah, 2019, November 2019. There's that one as well. I don't know if you'd rather that one very specifically, or do you want this one here? Because I've just found it. It was question 24. Yeah, we can go through both. Okay, let's do this one first, and then we'll go on to the one about the Z's that you said, that because I just found that. Okay, this one's pretty straightforward. As I said, part A is fine. So first of all, let's label what they've given us, and again, label obviously the direction as well. So A, D to E as a whole. The whole thing is B. F to C. Ooh. A minus B. So you can see that FE is pretty straightforward because you've got all the other three vectors. You just have to follow it around. So obviously A minus B plus A plus B, because we're going in the correct direction for all of them. And then that would simplify. Obviously they want you to simplify it. You should end up with 2A because the B's would cancel. So that's just 2A, which makes sense because you see how obviously they've said, well, I haven't even told you, but actually that means that these two are parallel. Just FYI. Those two are parallel, CD and FE. Obviously you can see that FE is just a bigger version. Anyway, that's 2 marks, so you should get that. Then they've said M is the midpoint of DE. M is often the midpoint, but if you see the letter M and they haven't told you it's the midpoint, then don't assume it is. But it mostly is, but just double check if it says. Sometimes it isn't the midpoint. So don't assume anything is halfway unless they tell you that very specifically. X is the point on FM such that we get this ratio to see n to 1. And then, do you see how they've also happened to mention, oh yeah, by the way, CXE is a straight line. Do you see how that's the line that crosses through the one that we actually want to find the scale for? So that's what I was trying to tell you in the previous one to identify. That, in this case, that's the line, CXE. That's the one we're going to find 2 vectors for. Okay? So I normally do it in the order that they've kind of given it to me. So it could be CX, CE, XE, any of those two. I normally do the bigger one because obviously usually the bigger one is the easiest one to find. So for example, I would work out CE first of all. I think that's kind of the most straightforward. So CE, you can either obviously go down and across or across and down. I would probably go across and down because the numbers are easier. The letters are easier even. A plus B. That's really straightforward, isn't it? Let me come back to my mark scheme. Yeah, if you just wrote down A plus B, that's already 1 mark. So that's pretty nice. And then I think I would go with CX. I normally just start from the same letter. That's just my own personal choice. So, and I also want to go along FX, F to M in the correct direction. So I would probably come down and then go across F to X. That's my, again, you can go the other way, but then you're going in the opposite direction to the way that they've written the ratio. So I would probably go this way. That's just, again, that's just my choice. It doesn't really matter. So I'm going to work out, what was it, CX. So I'm going to go the opposite direction down, so C to F. So that would obviously be minus A plus B. You'd have to swap the symbols of those. And then I would have to add F to X. So see how that, I now need to work out that bit there. So to work out F to X, I need to know F to M as a whole, and then I'll apply the scale, or the ratio in this case, to that. So F to M as a whole, again, you can go up and across and down, or you can go across and up, it's up to you. Let's go to E. So 2A, but then minus a half B. So we're going the wrong direction, and it's only halfway. Okay? So that's the whole line. I obviously only want to know the piece between F to X, so I need to apply, you know how in the other one I just multiplied it all by K? because that's how that question worked. In this case, I've got a ratio. So I want to convert my ratio into a fraction. I mean, I think you probably could put k here if you wanted, and then just at the end convert it back into a ratio, but I tend to just work with whatever they've given me. So in this case, converting ratios into fractions, we need to know how to do that anyway. You take, obviously, the ratio just as the numerator, so 1 would be n, 1 would be 1. And the denominator is always just those two added. So that would be, in this case, n plus 1, n plus 1. So that's the fraction of each piece of that line. Now, because I want the f to x fraction, that's the left-hand one, isn't it, based on the ratio? Arjun, I don't know if you're from, you mean grade as in the US grade system, or because GCSE is, yeah, I don't, it's for age 15 to 16, if that helps, if that answers your question. Age 15 to 16. So you can translate that to whatever grade. I don't know how grades match up in the US. Yeah, 15 to 16. Okay, so I'm using this fraction because I'm looking at the f to x side. If you were doing the other side, the x to m, which is fine, use the other fraction, okay? So do you see how f to x, this is why this one's a little bit more complicated. It's the same method, but it's just more annoying because you see how this fraction is just worse. It's worse than using just k, isn't it? There. Do you see how this is the scale? And then obviously I'm going to multiply it out. So I'm going to actually, wherever you've got space, I'm going to multiply it out now because you know how I said I want to collect my like terms, as in all the a's, all the b's. So multiply this out. You also need to be happy, obviously, generally with multiplying fractions. Not only with fractions, but with whole numbers. 2 is a whole number, so technically there's a fraction, 2 over 1. It will only affect the numerator, so that would be 2n over n plus 1a. I'm leaving the a separate because the n bit is the coefficient, isn't it? And then minus, and then obviously the fractions just multiply straight, so that would be n, and then the bottom would be multiplied by 2, 2n plus 2, or you can leave it in brackets if you want. Yeah, that's not like an n. Oh, that was horrible, let me redo that. There. And then that bit I'm going to add on. I'm adding it because I was going the correct direction, so I can add down here 2n over n plus 1. This one's just messier, which is kind of annoying because it's actually fewer marks. It's only 4 marks for whatever reason they decided to only do 4 marks. So you might decide that I'm just going to stop here because it's not worth my time. Do you know what I mean? Like that already, if you got up to this point, that's 2 out of 4 marks, which obviously you would have got part A, right? So that's 4 out of 6 marks of the whole question. You might decide, you know what, I'd rather spend my time somewhere else because it's not going to take, for the extra 2 marks, it's not going to take you 2 minutes probably to solve this, probably going to take longer. So you might decide, yeah, I'm just going to leave it there. Obviously, I'll show you what we'll do. Anyway, so we want to get A and B together, so I'm going to do exactly the same thing as I did before, where I factorized it. So this one for A, I'm going to put, I normally just like to put the positive first, but that doesn't matter, it's just my preference. The coefficient of minus A is obviously minus 1, so don't put 0, it is minus 1. And then B, coefficient of that B there is obviously 1, and then I'll put the negative 1 second. That's just personal preference in terms of the order, doesn't actually matter. B, so I've got something A, something B, obviously the original line CE, that's just 1, like that's a, try and draw my 1s nicely. That's a 1A and a 1B, isn't it? Those are the coefficients. So now I'm going to create my simultaneous equations. So A is 1 on one side of my equation is 1. The other side is all this. Now I also need to bring back in my other scale. Do you remember how we used x? I'm going to use x again. You can use whatever letter. So I'm going to put, I always put the x on the side where it's easier, which is obviously the 1. So in this case, it's technically 1 times x, which is obviously just x. So the 1 is still there, but I just don't need to write it. Is equal to 2n over n plus 1 minus 1. That's the A1. Then you do the same for the B. So you see how that's also 1 here, and then in this case 1 minus n over 2n plus 2. That's the other one. And also obviously multiply the same side by the scale x. Don't multiply different sides. Multiply the same side. Or the same coefficient, if you get what I'm saying. Now this one's a little bit easier in the sense that they're both just x. So in terms of solving my simultaneous equations, and in terms of obviously getting rid of x, because I don't actually care what x is the scale of cx, isn't it? Cx to CE, which I don't really, they've not asked me to work that out in the question. I just technically need to include it, but I don't actually need to know what number that is. So in this case, I'm just going to put them equal to each other. Do you see how x is equal to x? So I'm just going to put 2n over n plus 1 minus n is equal to the other side, which is 1 minus n over 2n plus 2. Now I've got an equation with just n again, so all you need to do is solve that. Now obviously that equation is kind of annoying, like it's not the most simple equation, but you can still solve it. Let's see, if I drag this, will it give me more space? Oh yeah, okay, perfect. Yeah, you can see it's only 4 marks, which is kind of annoying. I think if you got this far and you didn't solve it, that would be 3 marks. But you'd have to put them together, like it wouldn't just be the separate simultaneous equations, they'd have to be equated. Okay, so I'm probably going to get the ones together, I think, just first of all. You could solve this in different ways. Yeah, exactly. We're going to have to get rid of the denominators, aren't we? I was thinking the ones would cancel, but they don't, unfortunately. So I'm just going to add 1 just so I can collect the like terms. 2n over n plus 1 equals 2, just so we've at least not got 4 terms. We've only got 3 now. Now the other thing, you know that 2n, well, you could cross multiply, but also you could just multiply by this denominator, because you know how that one is just this one but times by 2. So it's you know, like if you have the denominator of 5 and the denominator of 10, if you just multiply by 10, it will cancel out both, because 5 goes into 10. I don't know if that makes sense. N plus 1 goes into 2n plus 2. So if I just multiply by 2n plus 2, then it will also cancel out the smaller one. So that, I guess, is kind of handy. So I'm going to multiply by 2n plus 2. Obviously, that would just basically cancel out the n plus 1 and end up making this times by 2, which is 4n, wouldn't it? So you get 4n equals, you can obviously write it out properly if you want. Just to save you time, basically. Obviously, you need to multiply this one by the denominator as well. You have to times everything by that. So that'd be 4n plus 4. And then that's just minus n, isn't it? And then if we collect the like terms, so 3n, if I move the 3n across, that's just n, isn't it, on that side, and then 4. Oh yeah, that one solved pretty well. I think last time I solved it differently. It took a bit longer. Anyway, so you should get 4. In this case, did you see how the answer is bigger than 1? Because it wasn't a scale in terms of less than 1, it was a ratio, wasn't it? If you look back here, 4 to 1. So that would make sense, wouldn't it? Because you can, like, we knew that the n side, if I come back to the picture, I know it's not necessarily drawn to scale, but it is in terms of the fact that the side that we were trying to find out was obviously bigger than the other side, so that makes sense. But I don't know if you can see that that's the same method. I don't know if you can see like the steps, even though it's applied to a different question, the steps are the same. That's what I'm trying to show, like there's a pattern. And if you can pick up on that pattern, and you can figure out on the exam that you've got the same type of question, you can just apply those steps kind of off by heart, basically. So yeah, up to you if you think that's worth 4 marks or not, basically. Yeah. It's one of those ones where I feel like I wouldn't know how to do it if no one showed me. Like, I wouldn't be able to guess, I don't think. But when I saw it and I saw a few examples that were very similar, then I was like, okay, yeah. That now makes sense. Okay, I don't know if you wanted to go through that other one, or do you feel like those two is enough to kind of summarize it? Just for the ratio ones, obviously make sure you're really happy with fractions. That's the other thing, isn't it? Also, I don't know if you guys are happy with the parallel proof. You know, it says prove these vectors are parallel, prove they lie on a straight line, because that is really straightforward. So make sure you definitely know that. So integrals is not in the GCSE syllabus. I don't know if you're doing IG. Oh, no, it's not even in IGCSE. So that's not within the syllabus. Yeah, we can go through the other one. That's what I was just asking, if you wanted to have that last. We'll do one last one, and then I could do about another half an hour. So whatever you want to fill that time with. Yeah, sorry, the integrals isn't in. That's, at least in the UK, that's more A-level. So that wouldn't be something that I would go through in this session. You'd have to look at maybe someone who does A-level maths, or I guess maybe American side. Let me make it. There we go. Get a bit bigger. This is the one I think you were referring to, wasn't it? This is also 5 marks. Yeah, that one. Okay, let's see if this is similar then. So, okay, let's label. We've got O to X, where's that? At the bottom is A, and then O to Y, oh, which is the diagonal one, okay, which is B, that's interesting. P is the point on OX, such that we've got OP, okay, they've given us a ratio for that. I'm gonna write 1 to 2 there, but that's not the vector, right? That's just a ratio, that's just a scale. R is the point on, okay, so we've also got a scale here. To 3, I'll annotate that in a minute. We can obviously split up the A's if you want and the B's. Work out in its simplest form the ratio ZP. Oh, it's crossing through, isn't it? To ZR. Okay, I feel like this seems similar, doesn't it? I mean, the mark scheme doesn't say the same thing, but let's see. So ZP to Z. Okay, first of all, so they want ZP as a whole thing, and then ZR as a smaller part. So it's not the 2 pieces, it's like the whole line and then a smaller part of the line. So we also have to pay attention to which part it's referring to. I think basically you just have to work out those 2 vectors and then take the coefficients to make it into a ratio. That's my assumption. Yeah, okay. Okay, so we can start, I guess, with these ratios. This is also a parallelogram. The other thing is to consider that. So whatever O to X is, Z to Y is the same. And then obviously technically O to Z and X to Y would also be the same as each other because they're parallel. Not only parallel, but it's a parallelogram. They're the same length as well, aren't they? So like technically this one up here is A. This one we could work, or this one over here we could work out. This one over here, you could work out X to Y, because if you went backwards, that's minus A to O, and then up here plus B. So that one would be minus A plus B. But because it's a parallelogram specifically, that one would be the same. You know how parallel vectors are the same, but maybe one is bigger than the other. But because it's a parallelogram, they're not bigger than the other. That we know that they are the same length. So they are literally identical. Obviously, the direction as well. So you could label that. Okay, so they've asked ZP to ZR. Let's see. Well, we could work out ZP, couldn't we? That's the first thing. Z to P. I can now go. Grab my highlighter. I mean, different directions, right? But you could go down here. And then this bit, we'd obviously need to share out that ratio though, wouldn't we? So ZP would be the negative of that, so that would be plus A minus B. And then O to P, so if O to X as a whole is A, we have to convert these ratios back into fractions. So see how I said in the previous one, you take the numerator as just those numbers, and then you add them together to get the denominator, so that would be 1/3. O to P would be 1/3. And then the other side would be 2/3 if you needed. Like if you'd gone that direction, you'd use 2/3. So do you see how that's then plus 1/3 A? And then obviously collect the like terms. So you've got 1A plus 1/3 A is 4/3. Leave it as a fraction, don't use any decimals because that would be kind of annoying. So that's Z to P. And then Z to R. Okay, what could we do? Oh, no, this is, okay, yeah. Because we could come down here again to O, and then if we share out the ratio for the B one, you could go up to R. Oh yeah, this is not the same, this is just a different question then, I guess, isn't it? We don't need simultaneous equations, I don't think. What was it, Z to R? Yeah. So obviously the incorrect direction, so A minus B, and then plus, this is 1/4, isn't it? Add them together, 1 plus 3 is obviously 4, that'd be 3/4, so that's 1/4 B, and in the correct direction. So if I add those, I get just A. So minus B plus 1/4 would be minus 3/4. Again, you just have to be really careful with vectors, with your fractions, but, well, it is a calculator, you could just type it in. Obviously this could come up on non-calculator though, so you have to be happy with the fractions. So we've got both. Okay, right, so that's the first thing then. How many marks would that give you? That gives you, for process to find ZP or, okay. I think that would probably give you 3. I think that's 3. I'm just trying to, so you know, if you stopped here, you'd get 3 out of 5. So that's still pretty good. Okay, so now the thing is we've got to put it into a ratio, isn't it? That's what they're saying is their last 2 marks. The 4th mark is to do the process of finding the multiples, and then obviously the final mark is the answer, the actual ratio. So it all kind of comes back to being parallel lines, straight lines, because ZP is the bigger version, isn't it? They're both the same line, they're the same vector, but obviously ZR is a smaller one, ZP is a bigger one. So what that means is they're multiples, as in the scale between the A coefficients and the B coefficients should be the same. And the scale relates back to a ratio, doesn't it? So you just need to work out, well, let's say if we looked at the A's, we're not making literally an equation or anything, but if you just look at the A's, technically that's 1A, isn't it there? That's a 1. How do I go, for example, from 4/3 to 1, or the other way around? And how do I go, and that this is -1. They're both minus, so in this case the negatives doesn't really matter. We're just looking at the scale, which is the numbers, isn't it? How do I go from 1 to 3/4, for example? Or the other way around. Let's go small to big. Let's go small to big. So that way around. And then, what was it? 1. That should be the same scale. Whatever I multiply 1 by to get to 4/3 should be the same as if I multiply 3/4 to get to 1. It should be the same scale because they are on the same line. So we know that they are multiples. Now they said this is calculator, so you could just divide it in your calculator, but obviously this one's kind of straightforward. How do I go from 1 to 4/3? Well, obviously I multiply by 4/3, don't I? That one's kind of straightforward. And then you could double check. Let me grab my calculator so you can see. Just make sure it's the same. So let's take the smaller one, which was 3/4 for the B. Oh, 3/4. And if you multiply that by the same scale factor, it should be the same. 4/3. We should get 1. Yeah, perfect. Okay, so I know to go from the small to big, it's 4/3. I think that would give you, that's mark number 4. Now, obviously, we need to put that into a ratio, though. That's the only thing. You then need to put that into a ratio. So it's effectively like a 1/3 bigger, isn't it? In this case, I think you can just take it, make sure they've got it right around. Yeah, the big one and the small one, that'll be 4 to 3. Because if you divide it across by 3, it'd be 4/3, wouldn't it, to 1? Like this, as in, I'll show you how it kind of made sense. That made sense to me. ZP, ZR. Because I went small to big, you can do big to small, but I went small to big, as in ZR is the smaller one. If I put that as 1, put whichever one used as your base one, I went small to big, so the small one is 1. I multiplied that by 4/3, didn't I? And then do you see how then you could just create the ratio? And it's simple. When I say simplest form, I think they mean they want it in whole numbers, and obviously the simplified version. So, or they have said or equivalent, so they might accept that. To be fair, they might do, but I think this is the official answer that they've given. So yeah, actually that was a different one. We actually didn't need to create those simultaneous equations as such. You probably could do it that way. It probably still works. I guess you're working out a ratio ultimately, aren't you? And then the line that crosses through. We didn't need to bring an x in though, because they actually did tell us the scale of the line that crosses through it. So I guess that was a bit easier. But yeah, I guess that one was slightly different, but it was just a case of working out the vectors as much as you can and then trying to create a ratio from there, because they should be multiples of each other. It should be the same scale between A and B coefficients. So I don't know if that answers your question for that one. That one was slightly different, but I kind of felt different, didn't it, that one? But when was that? That was November 2019. I don't know, maybe it's just me, but I feel like the November papers feel different. That might just be me though, that might not be actually accurate. But I feel like the November papers feel just slightly different or just a little bit harder. I mean, they shouldn't be, obviously, but they do feel it, I think. The questions are normally a little bit odd. So yeah, that was a November paper. But yeah, that's the vectors proof in terms of ratio scale. As long as you guys are happy with the parallel proof as well, because that's the other half of it, that one's much easier. Because they could ask you that, and then you're good to go. That one's really easy. Then, yeah, that's not too bad. And then obviously they could just ask you a random random vectors question where it just says work out this vector, which I feel like that's not normally too hard because you're just trying to find a vector. GCSE, from what I've seen from iGCSE, especially, I mean, I guess the Edexcel one, because I have a student who does iGCSE, is that, and they're doing higher tier, right? I don't necessarily know about foundation, but higher tier, their syllabus seems to be a bit longer, as in, from what I've seen, because I did normal GCSE, right? They have a few subjects, maybe 3 or 4 topics that I would class personally as year 12, which is A-level maths. But they have that in their iGCSE. So in that sense, you might think that it's harder because they've got higher level topics, what I would class as higher level topics like differentiation, things like that. And the other thing is that you only have 2 papers and they're both calculator, whereas the normal GCSE has 3 papers and there's 1 non-calculator. So you might find iGCSE is better because you have no non-calculator paper. You still have non-calculator questions, like there's still questions where you can't use the calculator. Is it? What exam board are you doing? Because I have a student who's doing iGCSE and they don't have a non-calculator. Did they actually? I might have to ask her. Just in case there is, because as far as I was aware, there wasn't one. Is it Edexcel? Is it? Well, I've only ever heard of Edexcel. I don't know if they do an iGCSE that's different, like AQA or something else. Yeah, I don't think it was last year. Oh, I might have to double check with her. Yeah, I don't know which you would think is harder then. I do think, well, maybe the syllabus has also changed then, but as far as I was aware, it was a bit of a longer syllabus than the normal one. So you might class that as harder, I guess. I'd have to see the grade boundaries as well. Depends on the grade boundaries, doesn't it? How many marks you have to get the same grade. I think your papers are longer as well. Are they 2 hours? Well, they used to be. It was 2 papers but 2 hours, whereas the normal GCSE is 3 papers at an hour and a half. So I guess technically it was less time for iGCSE in total by 30 minutes. I don't know. I mean, I think some schools choose it because they thought it was easier maybe for foundation. I don't know how schools choose which exam board to use, to be honest. It's kind of interesting to know that. But I would assume they would choose one that they would think most people would be more likely to pass, I guess. I don't know. I mean, the iGCSE originally still had non-calculator questions. Like, they would word it in such a way that you couldn't use the calculator even though you had one. So it doesn't make a huge amount of difference, I guess. It's more just making sure that you know how to do the basics, like fractions without a calculator, multiplying fractions, multiplying whole numbers with fractions, decimals, multiplying decimals, dividing decimals, things that you've probably forgotten about, because that, I guess, could come up. It's a lot of fractions, I would say. That's the skill for non-calculator. As you saw, it came up in ratio. We still have fractions that we need to be able to deal with if it's non-calculator. Yeah. Okay, so that was the vectors. I don't know if we've got about 15 minutes left, guys. So is there anything else you wanted to have a look at in the last 15 minutes this week? Anything else specifically? So tomorrow will be a past paper. Normally that takes me, it depends, because it depends if people interact and we are kind of talking through things, or if I'm just kind of going straight through it. So it will be between an hour and a half to about maybe 2 hours max. It depends how long it takes us to get through the paper, but it will be a non-calculator paper tomorrow. Edexcel non-calculator higher tier at 7 o'clock. I think it's I think we're going to do the November 2022, if that helps. So yeah, that's not necessarily a random question one. I think Sundays I'll just do this where you can ask specific questions, and then the ones during the week are actual past papers. From this week, we'll be going through just non-calculator until the non-calculator exam. So Monday, Wednesday, Thursday are all non-calculator papers. And then obviously after the non-calculator exam happens, then we'll move on to looking back at the paper 2 and 3 questions. We'll alternate, because obviously 2 and 3 are both calculator, so technically those topics could mix between them. You don't know which will come up in paper 2 or which will come up in paper 3. Yeah, otherwise, if you want to have a look at in the description, I've linked some videos that you might find helpful. I linked also a video that I did on hardest vectors questions, so you might want to have a look at that as well. Obviously, the questions we've looked at today will come up in that, but there's some other ones, I guess. You can have a look at those. You can also have a look at, I think I need to change one of the links. You can have a look at the most repeated Edexcel past paper questions as well on different topics, especially also vectors, because as I said, some of them there is a pattern. So that's quite helpful to know if you can guarantee that you know how to answer the most common questions. Those are probably quite good to boost your grade. Yeah, so I go live Monday, Wednesday, Thursday, right? We go through in this case, we'll be going through non-calculator papers from start to finish. And then I think every Sunday at the same time, I'll do, like an hour and 15 minutes of Q&A. So the non-calculator paper is in, where's my calendar? Hold on, let me grab my calendar. So we've got this Sunday. It's on the 14th. Okay, so we've got 2 more Sundays, which I'll do a live like this. So if you've got specific questions, we can go through those on the Sunday. And then 2 weeks of 3 papers a week, which will be live. And then obviously it's on the Wednesday, isn't it? So Monday we'll do another paper. I can go live on the Tuesday before and maybe have some final questions that you want to ask. So yeah, I will be doing quite a few lives before then. And obviously up until the second and third papers as well. Depends if you find this Q&A more helpful. I could always add more of those in as well, rather than a specific paper. It just depends, doesn't it? Yeah, whatever you guys find more helpful. But yeah, check out the description, have a look through the higher tier playlist I've made of different topics I've gone through as well. And yeah, check out, I've got that video which is how to boost your grade. Have a look at that, and then that's literally at the top of the description if you want to go up by a grade or so. Have a look at those tips. And then there's also a little bit further down, it says watch next, and it says top 10 mistakes. That's kind of a similar type of thing. So you could have a look at that as well, because obviously to go from, let's say we're going from 7 to an 8, you just want to be reducing the amount of mistakes we're making, aren't we? We just want to be getting as many marks as possible. So yeah, those 2 videos might be more so tips on how to kind of boost your grade. Those will be probably helpful for you as well. And then obviously the rest of them are all kind of content videos. And then the next couple of weeks I'll have videos that are coming out, not lives, but actual videos that are coming out of the most common non-calculator questions as well. So keep an eye out for, I think it's posting 3 times a week at the moment, keep an eye out for those. Because if you can see the ones that do repeat themselves, then that will give you a good kind of basis for the exam as well, isn't it? Knowing what might, has a good chance of coming up, specifically in the non-calculator. So yeah, I don't know if anyone has any last questions, anything else they want to ask to go through, apart from those vectors ones. Okay, see you tomorrow. Thanks for coming. Might just bring up the parallel one just as a last one. Copy it. There we go. This is the other type of vector, so we'll just do this and then we'll finish for today. This is 4 marks, so it's still a decent amount of marks, I guess. But this is a much nicer one because saying use a vector method to prove that PQ is parallel to FE. So I'm going to draw the line PQ if they haven't already. Obviously draw any vectors or lines that you find helpful. So if they say prove they're parallel, you just need to basically find those 2 vectors. And then at the end we'll prove that they're parallel, right? So let's see what they've given us. FD is equal to A. That's this whole line here, isn't it? A. And then F to E. Oh, they've already given us FE. Well, that's fine, isn't it? We don't even need to work that out then. So we've got FE, that's B. We just need to work out PQ then. So they've given us that P is the midpoint of FD and Q is the midpoint, so we know it's half and half. So to find P to Q, I would probably go up to D, which I know is half of A. So P to Q. Again, this method works in, if you're not sure what to do, just write down any vectors you can figure out, even if it's not PQ, just any of the others. So that's obviously half A because it was a midpoint. And then I need to then know D to Q. But D to Q would be half of DE, wouldn't it? So I also, do you see how I would also, kind of before then, I would have to work out DE. So D to E would be minus A plus B as a whole. And then do you see how D to Q is half of that? So plus half of that. So obviously now I'm going to expand and simplify this. So that would give me, obviously I've got half A minus a half A plus a half B. Now do you see how the A's cancel? And I'm just left with a half B. And then when we're proving that 2 vectors are parallel, we just want to show that one is a multiple of the other. Obviously I went in the same direction. One is a multiple of the other. Do you see how the original FE is B, as in 1B, and PQ is half B, which is a multiple of that, isn't it? It's a smaller version. So your conclusion, because it's obviously a proof one, you have to kind of give a conclusion. You don't need to write a whole sentence or anything, but what I would do is write, normally I write, you can write it whichever way around you want. I'm going to write the bigger one, FE is equal to 2 lots of PQ, isn't it? PQ is the smaller one, so I need 2 of those in that case because it was half. Or you could write it this way around. You could write a half FE equals PQ. Either of those, whichever one of those 2. So that's showing that it's a multiple. And then I would probably just put like a little, this is the therefore symbol, isn't it? Therefore parallel. That's what I would do. But you have to kind of put this little conclusion here, as in showing that one is a multiple of the other. So you see how FE is 2 lots of PQ, or PQ is a half of FE, whichever of those, therefore it's parallel. If they say prove it's on a straight line, you prove they're parallel first, and then you show that they have a point in common. Let me see if I can quickly find one of those, and then at least we've covered all the vectors pretty well. Oh, this one's not drawn, but it works the same. Why doesn't let me copy it? Hang on. copy, paste. There we go. Finally, let me paste it. So not part B, just part A. Ignore the part B. So A, B, and C are 3 points such that you've got A to B, the vector, is 3A plus 4B, and A to C, see how they overlap with the point A, is 15A plus 20B. So in this case, we don't need to work out the vectors because they've already told us. Prove that A, B, and C lie on a straight line. So you need to first prove that they are parallel. So that means they're a multiple of each other. So normally I just take the bigger one, obviously the 15, and then divide it by the smaller one. So the coefficients of A, obviously that would give me a scale factor of 5, wouldn't it, for A? And then I have to prove that it's also the same scale factor for B, because if they're parallel, they'll have the same scale factor. So take the big one again, divided by the small one, obviously 20 divided by 4 should also give you 5. So that shows me that they are parallel. So I would write that same conclusion as in, so I normally do the bigger one. So the bigger one, AC, is equal to 5 lots of the smaller one, isn't it? So that's showing that they're a multiple, which means parallel. That's the first thing. Then the second thing is, well, yeah, they're parallel, but they could just be floating around randomly. What is there to prove that they're on a straight line? Well, that last piece is just that they both have, in this case, they both have A in common. So you go share point A in common, therefore straight line. So it's not only are they parallel, but they're actually overlapping, aren't they, because of point A? So therefore, obviously, if you've got two parallel lines that overlap, it creates a straight line, doesn't it? They lie on the same line, they're parallel, but in the same location. So that's the other half of it. That's the really easy half. You just have to memorize that logic. Okay? So that's most of vectors. Obviously, make sure you know how to do column vectors. That's really easy, isn't it? That's a nice, easy couple of marks at the start of the paper. So make sure you know how to do that as well. Column vectors is also relevant for foundation tier as well. Not this, obviously. This is higher tier. So yeah, I think we'll leave it there, guys. Thanks for coming to this Q&A session. Tomorrow we have, as I said, a paper 1, past paper that we'll go through at 7 o'clock. So I will see you then.